So for loops allow you to iterate based off a count, such as execute this block of code 5 times. Or you can also do it through an iterable object. For example, you can say, for every item in this list, go ahead and print out the item, or go ahead and print a block of code every time you see a particular item show up in a list. You can also do the same for a set. And you'll see there's a special syntax of code we need to use to do it for a map, since a map is technically not iterable by itself. So let's explore the syntax for all these different cases before jumping into the code. We're actually going to kind of switch the typical order here. I'm going to show you examples of iterating through objects that are iterable before showing you the technically more common example, which is iterating based off a counting condition. So let's start off with for loops for iterables. The first one is a list. And remember, an iterable just means I can iterate through the list, which means I can just go through the list and do something. So I can essentially grab each item in the list. So the code is going to look like this. Let's break it down. So I have on the left-hand side my list, and then the for loop, and then on the right-hand side I can see the console printed out A, B, C, each on a new line of code. So what happened? Well, first I defined my list. My list is A, B, and C, and remember, lists do retain an order. Next, I have this line of code. You'll notice the syntax kind of looks similar to if and else. You essentially have a keyword, the for keyword, and then in parentheses, you have something that's not quite a condition. Instead, what we have here is I'm going to make up a variable name to temporarily define or access each item in the list. So I'm saying for this made up name variable, and I want to make it clear, you can really call this whatever you want. Notice it's not defined anywhere else. And then I can say in my list. So again, it's totally up to you to decide what that variable is called. And then you're going to say for every made up name in my list, and then in curly braces, you end up executing some block of code. So for made up name, and then I can access that made up name inside the block of code, which is inside the curly braces or curly brackets. So that's why I get to see made up name printed A, B, and C. Now, the one thing I do want to point out is due to the way we want to structure our code, we want to make sure that no one can accidentally reassign made up name and that it's actually just a final assignment. So to do that, we're going to replace this var keyword, and you will typically see for loops that iterate through objects look the same, except it has a final keyword. So keep in mind, the rest of the code is exactly the same as you saw before, except this time it uses the final keyword to make sure nobody can accidentally reassign made up name, and we make sure it is that particular item in the list. So this is a for loop for an iterable list. Again, you define the list and then say for final made up name in my list, then you do stuff with the made up name. In this case, I just printed it, which is why you see in the console on the right-hand side, A, B, and C. So that's iterable number one. I can just iterate or do something with each item in that list. Sets pretty much look exactly the same. So again, I created on the top line variable my set is equal to a set of 0, 1000, and 1. And then I have my for loop. And notice I'm going to say for final item in my set. Remember, final is that keyword we talked about when we talked about constant and final. We typically use that instead of just defining a variable, although they technically both work. And we'll say final item in my set, and then I can print the item. Now this looks a lot like the for loop for a list, and technically speaking, the syntax is exactly the same. But there's one major caveat for when you're iterating through a set using this notation, is that there is not a guarantee that the set is going to be printed out or used in order. So for very small sets, and really even like larger sets like 30 or 50 items, you actually don't really see this. The set object uses something called hashing to store items efficiently, but that all happens on the back end, and you don't really get to see that with your Dart code. All you need to remember is that if you are iterating through a set, there is no order guarantee. Although it might appear that way for small sets, you can see in this particular case, it looks like it's printing it out in order. On the right-hand console, I can see 0, 1000, and 1. You should not take it as a guarantee that the set is going to retain any order. And remember, the list notation allowed us to index specific items at specific positions. You can't do that with a set because the set doesn't guarantee an order. All right, so that's my little kind of caveat there. Make sure you pay attention to that. It's kind of confusing for beginners. They often say, well, it printed out in order, so I'm guessing the set's in order. That is definitely not the case. There's no guarantee of that. If you need order to be retained, use a list. But you can iterate through the same fashion and same notation and syntax with a set. Now, maps are not technically iterable, however, the keys of the map are. Fortunately, there's a simple method call to quickly get the keys, and there's also a special for each method call. So let me show you how you could iterate with for loops using maps. Remember, maps are key value pairs. So here I have a map. So I have a variable map, and then I want to kind of hone in on some of the discussion. Whoops. Here, let me bring out my little laser. So I've created a map variable, and I have key value pairs. There's key A and the value of 1, key B and the value of 2, and key C as in Charlie and the value of 3. So there's your map. There is an attribute or ability in the map to grab just the keys. And notice the keys looks a little kind of like a list. It's A, B, C. If you check the runtime type of this keys, essentially what data type or object is this? It's this special linked hash map key iterable. Main thing to note is that it's iterable, which means I can actually use the keys here. One thing to note is this one is a little unclear whether or not you're going to retain order. You should assume that the order is not going to be retained, although there's special methods you can use in order to retain the order of the keys in a map. But again, when you're thinking of mapping a hash map, that is the key value pairs, you shouldn't be thinking of things in order, because remember, you don't use index positioning for maps. That was a list. For maps, you use the key value pairs to grab items. So let's imagine you have a map, and for every value in the map, you want to go ahead and do something or print it out. How can you use the knowledge that keys is an iterable type? Well, you would just do a for loop, but instead of passing my map, you would pass in my map.keys. And so note the syntax here. I'm saying, here's my map, A1, B2, C3. Those are the key value pairs. And then I'm saying for every key in my map.keys, first print out the key, and then look up the map value at that key and print that out, which means I should see the key printed first and then the associated value for that key printed on the next line. And then I'll do that for every item in the dictionary in the map. And then technically speaking, the order is not guaranteed. So that's why I see A1, B2, and then C3. So that is one way to iterate through the maps using the mymap.keys, and you essentially kind of treat that as a list or set of the keys. It's this special linked hash map key iterable object. I also want to point out that because sometimes for looping through maps is technically common, there's this special method called for each. And if we take a look at for each, this is essentially kind of like a built-in for loop. So you don't actually use the common for notation. So you don't say for blah, blah. Instead, after defining your map, you call mymap.forEach, and then you say this little, almost like a tuple object, key value pair. Then you can access within this block of code the key and the value. So note here we're using some string formatting in order to print out the key and the value, so you can see the output here. But the real thing you got to pay attention to is you just call mymap.forEach, and then pretty much by convention you always say key and value, and then it's up to you to decide whatever you want to do inside that block of code. So this is only acceptable for maps, this particular method for each. Now, you'll often also see for loops doing incrementation. So this is actually the more common way to do for loops or seeing for loops. And I want to really break down this code because depending on what language you're coming from, this could seem totally foreign or it could seem super familiar. It depends on, if you're coming from something like JavaScript or Python. So let's explain how this for loop actually works. So there's three things to keep in mind. You're going to say for some initialization value, some condition to stop on, and then some increment. So you're going from the initial value, you keep incrementing usually by 1, and then you check is the condition met yet or not. So again, let's explain and break down each of these terms. You're not going to actually see these as keywords. We're going to replace them, and you're going to see our old friends, the plus plus sign. So initialization. This is an expression that is executed once before the loop starts, and it's often used to initialize a loop variable. Then you have the condition you're checking against. This is an expression that's evaluated before each iteration of that for loop. If the condition is true, you keep executing the code inside this for loop. Once the condition becomes false, the loop terminates. And then you have to go from initialization to some sort of end condition, and that's where the increment comes to play. This is the expression that's executed after each iteration of that for loop, and it's going to be used to update the loop variable. So these are the main terms you got to consider. It's an initialization, a condition you're checking for, and then an increment that you're going along via the for loop. So how does this actually work in practice? And this is what the default code sample in Dart is based on. So if you open up a new Dart pad, you see something that looks very similar to this. It's their hello world example. But if you're totally new to for loops, it might seem super confusing. But now that we understand the initialization, the condition to check, and then the increment, we can see what's actually happening here. So we're going to say for, and then we define some variable I to start at 0. So don't think of this now as iterating through objects. Instead, we are doing something for, we're deciding on our initialization of this variable for I, and then we have an end condition, I is less than 3, and then we have an increment. And you pretty much always see it as either plus plus, sometimes you see minus minus, but most programmers tend to think of iterating +1 positively. So what's happening here? Well, I'm going to keep executing this block of code as long as this condition is true. And I'm starting with I is equal to 0. So we're going to say I is equal to 0, and then I'm going to check is I less than 3. So on the very first iteration of this loop, I is equal to 0, that's less than 3, so I print out 0 here in the console. Then what's my increment? Well, my increment is I plus plus. Remember, I plus plus is just going to add 1 based off our previous lecture on this. So now I is equal to 1. Is that less than 3? Yes, so I print I. And there's 1. So then it's I plus plus, so now I is equal to 2, and then is 2 less than 3? That is true, so I keep executing my code, and now I print out 2. And then I add 1 to 2, and now suddenly I is equal to 3. Is 3 less than 3? No, it's no longer the case, which means the for loop is done running, so you only see the output 0, 1, and 2. And this is actually the more common for loop structure you'll see. It takes a while to get used to depending on what language you're coming from. If you're coming from other languages where this is kind of the main way of doing for loops, then this is totally natural to you. And remember, because you have an I here, this kind of implies indexing. So you could just use I and set something like I less than the length of a list. So we'll see that also explored later on. In fact, let's explore all these concepts with code in part 2. I'll see you there.